All right, so maybe I'll have to write up here. So we're going to try to solve for x. We have 2r plus x times r root 3 equals the side length of our square, 2. Okay?
Alright, so...
And when I have n squares across the bottom, n circles across the bottom of the square, what's my radius?
So you have...
So it's, you've got n circles?
Yeah.
It's 1 over n.
1 over n. Okay, so here the radius is 1 over n. Does that make sense?
Yeah.
Because I have 2n times r is 2. Right?
Alright.
R is 1 over n. Okay. So now I have 2 over n. Well, do you see what I could do to make this a little simpler here? This equation?
You can factor out an r.
Yeah, although I'm trying to solve for x, right? So, I have x equals 2 minus 2r times r root 3. Right, so this is, x is 2 minus 2r over r root 3.
Alright.
That's, x is how many total rows we have going up, right?
We want to know.
Alright, so now when r is 1 over n, I get 2 minus 2 over n over root 3 over n. So maybe I can multiply the top and bottom times n and turn that into 2n minus 2 over root 3.
Alright.
Alright. So x is 2n minus 2 over root 3.
Okay.
2 minus...
So 2 times the number of circles on the bottom over root 3.
Does that make sense to you?
Yeah.
Okay. So what is this going to look like as n goes to infinity?
So I think it's going to look like
It'll look
2n
like
over root 3.
Yeah, so maybe we'll just approximate this with 2n over root 3. So, and just say x is approximately. Oh.
2n over root 3.
Okay, and what is x, by the way?
X is the number of rows up on our triangle.
Okay.
Or square.
All right. So how many total circles do we have?
So
we have n plus n minus 1 times x over 2.
Okay. Yeah, that's good. So
And then I guess x has to be rounded down to the nearest integer.
yeah. But as n gets large, it won't matter. This obviously is never going to be an integer, but it'll, will be a plus or minus 1 on this.
all right.
So, that was a good way of thinking about it. N plus n minus 1, so 2n minus 1 times x over 2 times n over root 3. That's the number of...
It's a number of circles.
Yeah,
Approximately.
x over 2. And then what's this going to look like as n goes to infinity?
This will look like 2n squared
2n squared.
over root 3.
Yeah. Okay, and what's the radius of each circle?
It's 1 over n.
1 over n.
So then pi times 1 over n squared times that. So it's 2 pi over root 3.
Okay, and then now our square has area 4.
Yeah.
So we have to divide this by 4. So I'll put a 4 down there to get my percentage. And so I get pi over 2 root 3. Or what does that simplify to be if you move the fraction to the top?
So it's 2 root 3 times pi, or I guess you could just do root 3 times pi over 6.
Root 3 times pi over 6. And so root 3 is, we like to use what, 1.7
Yeah.
times 3.14 divided by 6 is about
0.889, so 0.89.
well, it's actually very close to 0.89. So that's actually a better approximation. Do you remember what we got with the pipe stacking?
I think it was about 0.78
So,
was our other way.
Yeah.
so even if you have to leave out some pipes, then if to get the lessened height of each row, then I think it would be better.
Yeah. So actually, it's actually if you don't approximate root 3 and pi like I did, you actually get about 0.91. So it's even our approximation
even
for rounding down.
Better.
Yeah, the 0.88. I thought it was above 90%. Yeah, so but you still don't get all the area. Just like
Yeah.
before, you still don't get all the area. Yeah, this is pretty cool. It's a good combination of these two problems. All right, good work, guys.